This is what a healthy service normally looks like. Latency is stable, the P50 and P95 look good. There is no downtime, and requests are returning successfully. But for a RAG system, none of this tells me whether the answer was actually right. The API can return a perfect HTTP 200, while the product is quietly giving users completely wrong information. So I added the layer that normal service monitoring is missing. Alongside latency and errors, SigNoz now tracks whether the retrieved context matches the question, whether the tool output is valid, how similar the retrieved chunks are, whether the knowledge index has drifted, and one composite quality score. Now I can see not only whether the RAG service is running, but whether it is still useful. To make failures obvious, this demo uses a deliberately unusual knowledge base. In this applications world, we live on Mars, and the President of the United States is a golden retriever named Barnaby. Those answers sound wrong in the real world, but they are correct for this product. Right now, the model is retrieving that private context. The quality signals are healthy, and SigNoz has no reason to raise an alert. Now I introduce a routing bug. The service does not crash, latency does not spike, and every request still succeeds. But the retriever is pulling from the wrong knowledge partition, so the model loses the application's source of truth. Mars becomes Earth, and the other answers fall back to what the model already knows. A single strange answer could be noise, a pattern is different. As these requests continue, context alignment and output validity collapse, and the composite quality score drops below its healthy threshold. Traditional monitoring still sees successful requests. SigNoth sees the customer facing failure that would otherwise pass unnoticed and turns it into an alert. That alert is not just a notification. SigNoth sends a webhook to Goose and the investigation starts automatically. Goose queries the live telemetry through SigNoth's MCP, finds the degraded traces, and compares what the question asked for with what retrieval actually returned. Here, it identifies a misrouted retrieval path and attaches the evidence and confidence behind that diagnosis. The diagnosis decides what happens next. A confirmed routing fault can be repaired, a damaged index can be rebuilt, but an uncertain failure is left for human review. In this case, the evidence is strong, so Goose restores the route and independently verifies the result before it marks the incident as recovered. And this is the part that matters. The fix is proven, not assumed. I asked the same question again, and the answer is grounded on Mars. Goose required the retrieval route to align and the quality score to recover before closing the incident. Across the full timeline, the normal infrastructure metrics barely moved, but the AI quality graph clearly shows when grounding failed and when it was restored. The full loop is driven by evidence. The RAG application emits quality telemetry through open telemetry. SigNoz detects the sustained failure, and Goose investigates through MCP, chooses a diagnosis matched action, and verifies recovery. The same loop handles routing faults, missing knowledge partitions, and empty indexes. It is not hard coded around one question. I previously placed in the top 30 at HackerX 6.0 while building a production level RAJ system among roughly 1,000 teams. Silent failures were one of the hardest problems we faced because everything looked healthy until a user noticed. With SigNoz and Goose, those failures become visible, explainable, and automatically recoverable.